thermodynamics being correct is the reason why we age, why it's easier to make a room messy than tidy it up, and why things break with time. Well, the room messy than tidy it up, well, I'm sorry. That's part just people being lazy. Well. First off, as you might guess, what I'm recording this for, happy Halloween to everyone who celebrates, of course. Happy Halloween, just generally. It is that spooky time of the year. All Souls Day, as we mark it in the Catholic calendar, but also All Saints Day is the following day. Even so, it's that time of the year. So I thought it would be a fun change of pace to talk about something a little bit spooky science related, such as the physics of ghosts. Now, I do know that some folks, when they have to deal with ghosts, get something along the lines of this reaction. Understandable, right? I could totally appreciate that. But this is more of a physics-based take on ghosts. How would science explain the supernatural? If ghosts are real, they ought to obey the laws of physics. So I figured this would be an entertaining thing for Halloween from this channel. Again, happy Halloween, everybody. But let's talk about it. From I Fucking Love Science. This spooky season, IFL Science is taking you on a journey between science and superstition, to a dimension of imagination akin to the Twilight Zone. For the next several hundred words, we are going to ask you to believe in ghosts. We will build a case for how ghosts can work within the natural laws of the universe before the scariest of all branches of physics comes to crash our fun. While physics is my domain, we need to raise a question that pertains to the world of biology. Why are ghosts in stories and folklore overwhelmingly human? And not just any human, modern humans, Homo sapiens to be precise. There is nothing in our biology or physiology that sets us apart for the task, or that is utterly unique compared to other species. Where are the Neanderthal ghosts roaming Europe? Why isn't there an ocean filled with ghosts of dolphins or orcas that have unfinished business roaming around kelp forests? Shouldn't poachers be haunted by the ghosts of great apes that they violently killed? Much to consider when you include biology, but for now, our focus is physics. There are 4 fundamental forces of nature based on our understanding of physics: gravity, electromagnetism, and strong and weak nuclear forces. Everything in reality interacts with these forces, not all of them, but at least one. An interesting example is dark matter, the hypothetical substance that permeates space and outweighs the regular matter that makes us 5 to 1. It is believed that it only interacts through gravity. Now, for our spooky spirits. We ought to have them interact with gravity at the very least. Otherwise, they should have helical residue of ghosts through space. Helical, like a spiral staircase, because the Earth goes round the sun and the sun moves forward within the whole solar system. Our telescopes and our spacecraft have not picked up such a trail. Another force that certainly matters to ghosts is electromagnetism. They are sometimes visible, although it is not clear, if they emit or reflect light. They can touch objects and move them, so there's a physicality to them that can be expressed through electromagnetic interactions. And they are translucent. Light changes as it passes through them. This indicates that a physical substance of some sort, which suggests that we might be dealing with one or both of the other 2 forces. For ghosts to be real, they need to play by the rules of the universe. The fundamental forces have put down some pretty stringent limits. Ghosts versus quantum mechanics. Gotta say, I love this. This is an entertaining piece for me. In the anthology, A Random Walk in Science, D.A. Wright delights us with a fantastic essay entitled A Theory of Ghosts. It starts from the assumption that ghosts can go through walls and doors, but remain confined within the thick exterior walls of castles and old buildings that allows us to do some intriguing quantum mechanical calculations. A standard exercise in quantum mechanics is a particle trapped inside a potential well. A particle has not got the energy to jump over the walls, in quotes, of this well, so it remains trapped inside, although it has the ability, occasionally, to tunnel through the walls. if they are not too thick. That sounds quite apt for the concept of a ghost, doesn't it? The conditions are so wonderfully stringent that Wright can calculate the mass of a ghost, around 10 trillion times less than a single electron. I mean, ghosts are supposed to be weightless, so that one kind of fits to be that little of a mass. Basically, ghosts cannot be scary or lift you up because any fight back from you could easily accelerate them out of the solar system. In other words, you would put a heck of a lot more force on a ghost than the ghost could put on you. But anyway, so our ghosts are bound by the fundamental forces, and they have a tiny mass, smaller than even that of a neutrino, aptly called the ghost particle. But maybe they are not just a thing. Maybe they are an interaction, like a time crystal. They periodically form from interacting atoms, appear to us in visible light, and then disperse again until it is time for their next interaction. Wouldn't that wrap up everything with a neat bow? Well, not quite. If you can't tell, this is a little bit of a rip on ghosts. Ghosts versus approximations. To make the science in the previous sections work, we had to cut corners and take creative liberties. If you start looking closely at every aspect of it, you will see how flimsy our constructed physics of a ghost is. For example, even if ghosts are immaterial, just magically made of light, they cannot pass through walls as long as we are seeing them. If they were made of radio waves or microwaves, sure, that's how Wi-Fi moves through a house. But we do not see Wi-Fi, and we wouldn't be seeing ghosts either. So this is the electromagnetic spectrum. For a little bit of a primer for folks, light, visible light that you see, is part of that electromagnetic spectrum. You can see it. It's waves of energy on a wavelength that you have the physical capability of seeing. This is not true of other things that are longer wavelength and shorter wavelength than visible light. Longer wavelengths are things like infrared. Radio waves, microwaves, Wi-Fi all emit in that sort of frequency of large wavelength, frequency, very small frequency thing. That's not the right thing. Large wavelength is the right way to say it. With that, likewise, solar radiation, amongst other types of waves in that shortwave wavelength spectrum, are also outside of the visible light spectrum of what you can see. So this is the thing. It's like, yeah, long wavelengths can go through walls, but you wouldn't be able to see it because it falls outside what your visible eye can see. The jokey tunneling example of quantum mechanics could not possibly work as long the ghosts were made of something. It would be like you were trying to tunnel through a wall. Yes, the possibility exists that as you run at the wall, all your particles would align in a way that you can phase through said wall. But the probability is so close to zero that it is easier to bet on your broken nose. Yes, unfortunately, don't do that. Even dramatically reducing the number of particles of the ghost would take enormous coordination to make that happen, and that means energy. Ghosts versus thermodynamics. This is why we left the scariest branch of physics to last, thermodynamics. The laws of thermodynamics tell us how energy is transferred, never created or destroyed. Remember, first laws of physics. Energy cannot be created or destroyed, it's only transferred from one form to another. And how entropy tends to increase in an isolated system. We cannot even reach absolute zero or create order, reduce entropy, without wasting energy. Basically, they explain to us that the universe is a big game. We can't win. No energy out of nothing. We can't draw. Entropy increases. And we can't even leave the table. Our physics-based ghosts have to face this impossible challenge. Either the well-tested laws of thermodynamics are real, or ghosts are. I'm more inclined to disbelieve the former, and then I am inclined to believe the latter. Scientist and educator Marcus Siddall told I fucking love science. If they exist in the universe, ghosts must obey the laws of thermodynamics. For a ghost to exist, it needs to draw energy from something, and it will expend energy to float about, change shape, and pass through walls, so that means it must also release said energy. Not to be all Demi Moore about it, but ghosts are hot. If they have to be real. When supernatural TV shows have cold spots in infrared cameras, that's a draft. A real ghost obeying the laws of physics would need to run hot. Since we are on the topic of tropes, what about flickering candles and such? The Spooky Science Sisters gave us a fantastic tidbit. Infrasound, frequencies lower than the human ear can hear, can make candles flicker. Thermodynamics being correct is the reason why we age, why it's easier to make a room messy than tidy it up, and why things break with time. Well, the room messy than tidied up, well, I'm sorry. That's part just people being lazy, myself included at times. So not just thermodynamics on that one thing, frankly. And that's way spookier, upsetting in the long run than any ghost. So obviously they're not talking about some religious related arguments and things like that for ghosts and angels. I'm not getting into that. But they are talking about ghosts per se here in a very tongue-in-cheek and fun manner. With what, if there is a ghost, can you have one that exists in line with the laws of physics? Explaining the supernatural, as it were. So I figured that'd be a fun read for us. Tell me what you think. Do you think ghosts are real? Do you think you can have a ghost that complies with the laws of physics and all that jazz? And so let me know what you think on the way out the door and all that jazz. And as always,
may you have a happy Halloween, my friends. May you have a happy Halloween, and may you always stay curious.